Okay, we're back. Okay, so first things first, apologies for taking so long with this video. While in the middle of doing the other tutorial series, my computer died on me, and once I got a new computer, my fiber died on me, so I had no internet. So I'm finally back up again. I have a new PC, and I have stable enough internet to do this. So let's get going. So just to kind of recap where we were on this kind of first-person controller video series, is at this point we had done the movement with the animations. So we can look around, we can move, we can jump. And if we go and play it in not maximize on play, we'll see the character at the top here playing all the correct animations. So just again, a recap of what we did up to this point. Because in this video, I'd like to cover the sliding. So there we go. All the strafing is working. I can look around and the animations play according to where I'm looking at. So the first thing I want to do is kind of fix this where the camera cuts through. And that's just the clipping plane. So let's fix that. That's a quick fix. So I'm going to go into my character controller. I'm going to find my camera and I'm just going to change the clipping plane, the near clipping plane. Probably let's go 0.01. That might be a bit too much. We can see the inside of the head. Let's try. Yeah, 0.175. Again, depending on the size of your character and all that stuff. So let's just see if that resolves the issue. So we don't want to see through the character. So if you're going to do something like this, probably going to want to set up your character correctly, probably remove the head from the model unless it's a multiplayer game. And even then, you can have it turned off on the single player on the client side, but on the server you should be able to see the head. Okay, there we go. So that's fixed. That's working. I just applied my prefab like I always do, just to make sure that my settings have been committed. So now we're going to go back into the code and start adding some code at the... Let's just do it at the bottom here. So we're going to do it at the bottom here. We're going to... Just going to get my reference. Okay, so something I realized with, I normally just copy and paste this update in Bolt, and like you know, if any of you who do coding will know that you can only have one update. So while building up this project, I kind of realized something stopped working the moment I started to duplicate this Unity event more than, I think it was like 3 or 4 times. It started to kind of become inconsistent. We'll keep doing it for now, but I'll show you the way you should do it. But for now, we'll just keep duplicating this for the time being. Okay, so we're going to duplicate the update. We're going to bring it down here. And from here, we're going to do a branch because we want to know a few things. I only want to slide when I'm moving and if I've pressed the correct button and if I'm not currently already sliding. So you can't just spam the slide button. So we need to answer these questions. If we can answer these questions and they all come back as the relevant answer, and we also need to be on the ground. So we need to be grounded, we need to be not sliding, we need to be moving forward, and we also need to be moving, pressing the move button. So let's just ask all of these questions and see what the result is. So we're going to start by dragging from the branch and just type in and. First thing I'm going to do is make sure that I am grounded. So I'm going to grab my grounded variable here and plug it into here. So we do need to be grounded, and I'm just going to drag this across and duplicate it again. So we're going to ask, are we grounded? And then we have to ask a few more things. So over here, we're going to ask if we're sliding, if we're not currently sliding, and we are actually pressing the input of buttons. Okay, so just so that we don't have to type all of that in again, I'm just going to grab the action list, the list get item, and we are just going to grab the triggered. So when we've pressed the button, I'm just going to duplicate those 3 nodes, bring them down here. Remember, we'll need to change the index value based on where in the list the input is. So we're going to drag that off and we're going to say if this, and from down here, I'm just going to drag in and do a equals. So if it is equal to, and the bottom one is going to be if we're not sliding. So I'm going to do a bool literal and leave it as false. And we don't have the sliding variable just yet. You can see that we don't have it here. I'm going to put it in the graph section of my variables. I'm going to click on here. I'm going to type it. Let's call it is sliding, or can slide actually. just call it can slide. It's going to be a type boolean, and it's going to be false because we're not sliding when we start the game. So we're going to drag that in and plug that in. So as it stands, we are going to, if we are pressing the input and we are not sliding, then we're going to be able to slide. So these input values are going to be based on what the action list, the actions that we've set up. So we're going to make sure that we set up a key for our sliding. And if that's true, and I forgot, I've left one out because I don't want to just say, okay, if I'm just pressing the button and standing still and I start to slide, you could leave it like that if you want. I feel that it's a little weird. I feel like a sliding will only occur if I am actually moving. So I'm just going to add one more and in here. So I'm going to duplicate the and again, plug this one into the top, plug that one into the top there. And the last thing we want to make sure is that the variable we created to store all of our movement, so down here, movement input, I'm going to drag that in, and I'm going to say if the movement input vector2.y, which means we're going forward, and if this is greater than 0. So that means if we're pressing the button in the positive direction, which means we're pressing the W key on the keyboard, or we're pushing the analog stick away from us. So if that is true, we are going to be able to slide. So we have to be moving. We have to be pressing a button. We also have to be able to slide because we're not currently sliding. And then the last thing to check for is, are we in the air or are we on the ground? Because I don't want to be able to slide in the air. That's going to be weird. Unless this is, just keep in mind that this can be used for a dodge system as well. It's exactly the same logic. Or a roll, unless you're using root motion. So actually even the same thing really. But I'm going to be doing my slide based on code and not on root motion. I find that certain things work really nicely in root motion. This slide could work quite nicely in root motion, but I just want to be able to adjust based on my level design how far I would like, for how long I would like to slide. So if I'm basing it on animation, I would have to go in and out of, like, from here to back to Blender, tweak the animation, go back into Unity and back and forward till I'm happy with the animation. So again, you can use root motion for this. I do find root motion for things like this can be really nice if you've designed your level, in such a way that you know exactly that every time you slide under an object, it's always the same distance and you'll never get stuck under the object or anything weird, then I think you could use root motion for this. So let's go and set up this action that we're referring to here. So I'm just going to go to my settings folder. I'm going to open up my FPS inputs. Just dock it to the, whoa, let's try that again. I'm going to dock it to the top here. And now my Unity decided to crap out. There we go. Okay, so we do have a jump, a move, and a look. We just need to add a new one. So I'm going to add a new action. We're going to call this one slide. And I'm going to bind, and it is a button, that's correct. So I'm going to add a new binding to this. So I'm going to click here, and I think I'm going to use the left control for slide. Come on, pick up my key buttons. Is there a new broken? Okay, normally if you press to listen, it will listen to events, but it doesn't seem to be doing this here. I have updated Unity quite a few times since I came back as this project, so I probably should go and check if I do have the latest input system. We'll do that after this. So I'm just going to go to keyboard. I'm going to go to where should it be? Yeah, it should be on the keyboard. Not that one, clearly. And we're looking for left control. That's right control. So we're just looking for, you could also use shift, but I'm thinking maybe later on I might want to use shift for when I'm sprinting. So left control, there it is. So I've now assigned my left control, and now I just want to go ahead and assign my gamepad. Oops, don't do that. Click on here and click this plus. And this one will be assigned to, let's just say, I'm playing the game and I'm moving around. I probably would like to use maybe the left or the right bumper button of the gamepad. So let's make it the left shoulder button. You can also choose the right shoulder button. That's up to you which one you feel more comfortable using or how you feel the setup should be. So that's going to be our slide. So remember 0, 1, 2, 3. So we're going to be putting 3 inside of our flow graph here. So when we're doing our sliding here, where it says 0, that I just duplicated those nodes, I'm going to put that as 3. And then we're just going to debug this really quickly to see if it works. So if all of this is true, I'm just going to do a log, do a debug.log. Just going to put in a string into this and saying, let's just say sliding. If I could spell sliding, that would be great. There we go. And let's see if that works. So I'm just going to go over to the console. I'm going to play the game. So remember, I'm going to hit the control button under all the different cases, situations that I said. So if I'm standing still and I press control, nothing should happen. If I move forward, if I move backwards, nothing. If I move forward, notice how it's fired off sliding. But if I go left and right and I try to slide, it won't work. Only when I'm moving forward. So therefore, the system is working. It is firing off sliding. So phase 1, it is actually calling this event and all of this logic is working. So now we need to go in and just create some the logic that comes after it. So first thing I want to do after we hit here is tell it that we are currently sliding. Sliding is not the right name. Let me rename this quickly. Let's call it is sliding. I think I should have just gone with my gut originally. Now remember when you do this, oh, it already exists. Where? Where? Did I already? I think we created in the last video. So I'm going to delete that and just use the existing variables. So over here where I'm looking for the sliding, I'm just going to go and grab is sliding. So if is sliding is false, I'm just replacing it. Because remember, even if you rename a variable on the left here, it doesn't mean it propagates through to the rest of the graph, which is really sad. It's something that something like a blueprint in Unreal does do that for you, whereas this it doesn't. But it's a simple enough thing to look for and fix that up. Okay, so now that that's true, we're going to set this variable to be true straight after. So if we are currently sliding, we're going to set it to true to tell the entire system that we are now sliding. So that while we're sliding, we'll never be able to spam the button until the sliding is complete. Okay, so I'm going to be using velocity or force to drive the character forward. So when doing that, I always like to kind of, before I do anything that's precision-based movement, like jumping, I always kind of like to zero out that movement, any velocity before adding, because I don't want it, velocity is exponential. So if I'm already moving in a certain direction and I hit the slide button and I add force on top of the current moving forward force, you're going to get inconsistent results. So after I tell the software I'm sliding, I'm just going to drag across. I'm going to type in rigid body dot velocity set, and I'm leaving it as it is. I'm setting the velocity to 0. Just for that one time where I hit the button, I'm zeroing out all velocity and I'm going to assign a new velocity after the fact. Okay, so the next step is to adjust the capsule collider. So the capsule collider, even though we're sliding, we want to be able to go slide under objects. So let me just duplicate this for a sliding case. So I'm just going to duplicate this, move it across. I'm going to pull it off the ground by maybe, yeah, that looks at the right height. So we're going to slide underneath this. I'm also just going to make it a little bit longer. A little trick I like is sometimes I like using the rect transform just to adjust and manipulate objects. It was designed for UI and images, but it works quite nicely if you use it to kind of scale objects around in the world. Okay, so I think we would probably want to slide under something that deep and that low. Again, let me just call this sliding obstacle. And now we're just going to go and try to slide out. This might be a little low, but if you look at our sliding animation we got in the previous video, there it is. Just look in the bottom right here. It's kind of this, the character does get quite low, so I might need to adjust this once we get this set up, but I just want to kind of get the gist of what I want to do. So here's the capsule collider. So the way we normally do this kind of thing is we're going to take the height of the capsule, and I think I'm going to make it I'm going to divide it by half, because if you think about when you're crouching, you're about half the height of when you're standing up. So I'm using that kind of logic. You can tweak this value. So I'm going to take the height and I'm going to make that 0.9 instead of 1.8. And then I'm also adjusting the Y offset, so that, because when you move the, let's just show you what that means. If I go and adjust the height of this capsule that you can see in the view here, and let's go and make it 0.9, it's kind of stuck in the middle of the character, so you need to then offset that by half. In this case, it's 0.45, and then it's on the ground, so that the collider that not only gets smaller, but it also repositions itself to the feet. So that's what we're going to be doing in code every time we slide. Okay, so let's do that. So we're going to go into the code, and I'm going to create a variable that I'm going to store the original height of the capsule, which is, looks like we went and created all of these variables, which is great. So here's my capsule height. So I'm going to grab this variable, I'm going to drag it in, and at the start of the game, I think we have a start up here somewhere. Yes. So at the start of the game, we're just going to grab the capsule height of the character. So what is the character's capsule height? So I'm just going to type in capsule collider dot height, and I'm going to get the height, and I'm just going to plug it directly into there. So we're getting the height of the capsule collider that we can then do some math with this. So we can always come back to the original height. So this prevents us from having to type any like try to remember what the value is and then hard coding it in code. I prefer to just store that value, so that if we do change the capsule collider in the editor at any point, we don't need to come in here and worry about updating that value. It'll get that value from the capsule collider and feed it into this variable. Okay, so back down to where we were. So now that we've reset the velocity, I'm going to adjust the capsule height. So let's drag this and type in again, like we did earlier on, capsule collider dot height, and this time we're setting the height. And what we're going to do here is we are going to, in my case, remember I said I'm doing it by half, so I'm just going to grab the capsule height over here, and I'm just going to divide that. There we go. And what am I dividing it? I'm just dividing it by 2. Like that. So if it's 1.8, it's going to become 0.9, and if whatever the capsule height value is, it's now going to become this height. So whatever the height is of the capsule, I'm going to divide that value, and I'm going to set the capsule height to that new value. Okay, so the next thing to do is to reposition the capsule collider's center. If you're wondering where I'm getting that from, if I look at the capsule collider component on the right, these are the names of what we're looking for. We're looking for the center. I just did the height. I'm now going to do the center, and I need to offset the Y position so that it's back on the ground. And remember, if you start to notice this, the Y offset is always half of the height, because the capsule's origin, or the pivot, is in the middle of that collider. So if I adjust the collider's height to 1 meter, then this would have to be 0.5. So whatever it is, the Y offset is always half of the height for the collider to be from head to toe. Okay, so what are we doing here? We're going to drag off this and type in, again, capsule collider dot center set. Okay, and remember, we only care about the Y position, not the X, so we'll need to just break this out and get a new vector 3, X, Y, Z. Like that, and all we're going to do is plug the result of this into the Y, because remember, this is already half of that value. So the capsule collider divided by 2 is already half, which means that's how much we need to move it by. Okay, so we're doing all the kind of setup at this point. We're telling it to reset all the velocity, tell it that it's currently sliding, reset, change the height of the capsule collider and the position of the capsule collider. Okay, so now that we're done here, we have one more thing to do, and this depends on whether or not you want to be able to control your player. So in the previous video, we created a can control player variable. If you see, we should have it set up before the movement over here. So I don't want to be able to, while sliding, be able to move left and right. So I always create a variable called can control player. So can we control the player when we're jumping? We could set that to false while we're jumping, if we don't want to be able to control the player. Can we move while we're sliding, that kind of thing. So once I'm sliding, I want to be moving in that direction until the sliding is over, then set can control back to true. So at the end of all this, I'm going to grab can control. Where are you? There we go. I'm going to plug it in here, and I'm just going to set this to be false. I don't want to be able to control the player until I've stopped the slide movement. So all of this is kind of heavily based on games like Mirror's Edge, and most recent for me was Ghost Runner. There's a lot of really nice kind of grappling mechanics, sliding mechanics, wall running. So now that we've set up, this is all for when you press the button, this logic here. So I'm just going to put a comment group around all of this. Hopefully it'll work. There we go. Let's call this activate sliding. So this is activating sliding. This is when the sliding gets called. We're just setting all the default stuff. So this will only fire once, because remember, we're telling it that it's being triggered. So when we press the button, and then straight after that, this update gets locked off because sliding becomes true. We reset the velocity. We set the capsule height to be half of the current capsule height. We reposition the center based on that value. Oh shit, no, my bad. We need to divide this one more time. What am I doing? Because then the character it's going to be in the wrong place. Let's do this. Of course. I knew I was forgetting something. We're going to divide this again one more time, because remember, we've divided this to get us the height, and remember the offset has to be half of the new value. So we get the new value, we divide it again by 2, and we plug that into the y offset. Okay. So let's test what happens when we do this. So I can show you in the game what the capsule looks like once we've pressed the button while we're moving. So you'll see the capsule goes from head to toe on this scene. I'm just going to go into wireframe so it's easier to spot this. So there's the collider. It's really easy and visible. So I'm going to run forward and press the button. Now that we've stopped, notice how the collider is from about the waist down to the toes, and it's been repositioned to the floor. So that's exactly what we want. So that this collider will be able to slide under, let's try that back to shade it, underneath this object and get you through to the other side. Okay, so we now know that works. So now all we need to do is the actual sliding part of the system, which is what we're going to do down here. And because we're using physics, I'm going to add a fixed update. And in the fixed update, all we want to make sure of is that we are currently going to be sliding. So we're going to add a branch. And the branch is going to have 2 requirements. So we're going to do an AND. Okay, 2 requirements. So the first part of the AND is going to be asking whether or not we are currently sliding. Sorry, something is happening weird on my other side. So sliding needs to be true. So first of all, that needs to be true. And the next thing that needs to be is that we still have that our sliding current time. Let me just see if we created that. Yes, we do. We have our current sliding time. So I'm going to drag that in. If this is greater than 0. So whenever you do a timer kind of system, you can either count up or count down. I find that counting down for me just makes a little more sense. Just for me, that makes no difference whether you're going up or down, to be completely honest. It's just how you kind of want to set up your system. So all we're doing here is we're asking, are we sliding? And is the sliding current time greater than 0? Therefore, that means we should continue doing the sliding motion, which is what we're going to do after this. Okay, so after this, we are going to grab the sliding current time and hold down Alt and drag it in to do a set and a get. And from here, we're just going to remove time.fixed delta time from this. So we're going to subtract time.fixed delta time. And we're going to update that amount there. After we've updated that, we're going to actually physically move. This is where we do the moving now. Again, you could use force. I prefer velocity when I want consistent results. Velocity is always kind of a nice movement, whereas force, whether you're using force, acceleration, or impulse, like for a single jump, when I hit the jump button, I just add an impulse of movement, then I'm fine with that. Whereas this one, if it's happening over a given amount of time, I prefer to control that using rigid body dot velocity. So we're going to drag off this and type in rigid body dot velocity set. And we're going to split this because we don't want to affect the up and down movement. We want gravity. So if you were to slide off an edge, we want gravity to take hold. And we only really want to move in the forward direction of the camera, not in any of the other. So we're just going to create a new vector 3, X, Y, Z. And we're going to plug a few things into here. And the things are that we're going to start with start right on the way on the left. And we're going to go and grab, well, we might as well, I think we might have created all the variables. Just double check. Because if we did create all of them, we should have a variable called sliding speed. There's your normal speed. Because you might want to slide faster than you move. So I create a new multiplier. So let me just see if I see a sliding multiplier here somewhere. We have a jump multiplier. Okay, so let me just add it. So I'm going to add a sliding multiplier. I'm not quite sure how much I want to slide by. So I'm going to just kind of take a look at how much we're moving at. So moving at about 250. So I'm thinking maybe I'll make it 300 for the slide. Okay, so I have my sliding multiplier. I'm going to drag that in. And we're going to be multiplying this again like we always do with force by time dot delta time or time dot fixed delta. Your English. So it's not my friend these days. Okay, so let's multiply this to do that first. So we're going to I'm going to multiply this value. And this is going to be the speed value to move the character in the forward direction. And then the other one that we're going to be doing is we're going to essentially let me just think this through. Yes. So let's do the one at a time. So this one here needs to be multiplied by time.fixed. Sorry, it's been a while since I looked at this project, so my brain's a little done. Okay, so there we go. Take the sliding multiplier again, multiplied by time.fixed delta time to give us consistent results on different frame rates. Then we're going to multiply that again. We're multiplying this by the transform.forward. So again, just a reminder, the transform.forward is the forward of the object that in its current direction. So if you're looking left, that will be the character's forward direction will adjust based on, like you, if you move your head left and right, up and down, wherever you're looking, that would be your transform.forward. So we're saying we're going to slide the character in its forward direction. There we go. And we're going to be combining that with we're going to zero out any of the side movement. So we're just doing that for our forward. So let's just drag off here and type in add. I think I'm just going to add it like this. There we go. So we're adding this, and then the next one is going to be using I'm just going to use a float literal because I'm going to zero out the right movement. So I'm going to take no right movement, and then I'm going to multiply that again by, actually it should make no difference. I don't need to multiply 0 by anything. I don't know what I did there. But anyway, let's just do a straight up normal multiply. And this time we're multiplying by transform dot right, exact same concept as forward, but it's always going to be right of the character. So if you turn left, your left will always be the left of you, not the left of the world. Okay, so there we go. Multiply those two values together, and then we're going to combine them. So now we've multiplied the forward movement by the sliding multiplier. We've multiplied the right movement by 0 so that there is no possibility that we'll have any side-to-side movement. And we're going to break this into our x and our z. Hope this is making sense, but I'll just talk it through once we're done again. So I'm going to drag off this and type in v3.x for my side movement. I'm going to do a v3.z for my forward movement. So I'm going to plug that into z, plug that into x, and all that's left is the y. And the y I'm just going to copy from our movement up at the top here. It's going to make my life, it's going to save me a couple of seconds if I can find it. That is player movement. There we go. So I'm just going to copy the rigid body and the vector3.y. So I'm going to duplicate that and move it down here. I'm going to plug that into y so that gravity will still have an effect on this character. And we've had velocity. So let's start again over here. All I did was I grabbed, let me just try to neaten this up so they're not so spread apart so it's easier to follow. Okay. Okay, so I'm taking the sliding speed, I'm multiplying it by fixed delta time, and then I'm multiplying it once again, the result of that, by the forward of the character, and then I'm adding that to the right, transform.right, which I multiply by 0, so this result will always be 0. And then I split that into the required axes that I need, the x and the z, and then the y just comes from the up and down, which is our gravity. So I took rigid body dot velocity get, I got the vector 3.y, which is the up and down gravity, and just plug that in. And that's it for the sliding aspect of it. So this is what's going to cause the sliding to happen. As long as sliding current time is greater than 0 and we are sliding, it'll do the sliding code. So let's just put a comment around just this section, just so we can see that. Let's call it sliding system. Could be a dodge system again. Remember, you're not locked down. Anything that you want to move a character over a certain amount of time. What's nice about using something like a rigid body, or you could use a rigid body.move position. You could even use the translate, as long as you have a rigid body in the object. You won't be able to slide through other objects that have colliders, and you won't be able to teleport through them. You can only slide as far as within the colliders that you have. So I can slide into a wall, and I won't slide through the wall. Okay, so that's my sliding system. And then so all we have left now is at the bottom here, when this becomes false. And what are we going to do here? So I want to do one more check again over here. Before I go and do anything crazy, at the bottom here, I want to make sure that I'm just actually going to grab we'll grab these and I'll show you what we're going to do. We're just going to duplicate that so we don't have to type all of that out again. I'm just going to replace the and this time. So if we are still sliding, and we're going to replace that node, and we're going to go equal or less than. Let's type in less. Less or equal to. If it's less or equal to 0, then we are definitely out of... oh, Jesus. What am I doing? Sorry. I replaced the wrong one. Let's do that again. I need to replace this one. So that's fine. I need to replace the greater than. Replace and go less or equal to 0. There we go. So now if we finally reach 0 or even less than, because remember we're dealing with floats, so they don't necessarily always round up or round down properly. So that's why I always kind of go less and equal to something, or greater or equal to something. Okay, so if this is true, then we're going to essentially reset the entire clock. So give ourselves some room here. Starting by setting the current sliding time. Where did I put that? Okay, let's go back here. So we're going to reset our sliding current time. So I'm going to hold down Alt and drag this in. And we need to create a variable that we will update this value with. So I do that in the object because I want to be able to access that in the editor. So right at the bottom here, I'm going to call this one sliding time. So what is the amount of time I want to be sliding for? And then I'm going to update, refresh the current sliding current time back to that value. I'm just going to see what I set my sliding time on this end for. I had good enough eyesight. There we go. I think I did it for half a second. So I'm going to make it 0.5. That's how long I'm going to slide for half a second. Once we're running out of sliding time, I'm going to reset that. I'm going to move to the left, and we're going to redo all of the stuff that we did before. Over here. So we're going to quickly go to the top here where we did the capsule collider. Let's just copy everything from this capsule collider all the way to the other one so that we can just easily remove what we don't want. Okay, plug that in after the sliding time. And I'm going to delete this first divide and plug the capsule height directly into the height, because remember we want to reset the height back to the way it was. And then plug that into the second divide that we had there. Because remember, whatever the height is, we still need to divide that value by 2 to get the capsule offset. And then now the capsule collider will go back to the height that it originally was. That's why we stored that value at the beginning of the game. Okay, and then all that's left to do here is I haven't actually technically played the animation, so we'll come and add the animation at the end. But there's one more thing we need to do at the end here. We need to... Actually, there's two more things. How did I miss that? Well, go to the graph, hold down Alt and drag in is sliding, and hold down Alt and drag in is can control player. Because once we're at the end of the sliding, we want to set sliding back to be false. And the can control player, we want to add a bool to that and set that to be true. Because after the sliding is done, we should no longer have be sliding anymore, and we should be able to control the player again. So this is our reset slide system. That should be it. So let's just move all of this together. Try to keep your code neat, especially when you're doing visual scripting. Coding can just be as messy, if not worse at times. Just try to find a nice way to maybe even do super units, which we'll do further along when we're doing the raycasting for the wall run. Okay, that's it. So I'm just going to put a comment group around this. Just say reset sliding. Just going to slide it underneath here. The only thing I want to do is just grab this sliding time and current sliding, just duplicate those two, and let's go put that in the start. When the game starts, we want to make sure that we update that sliding value, or we're not going to be able to slide for very long the first time we do it. There we go. So at the start of the game, we're going to make sure that the sliding current time is set to the correct value, which is at this point 0.5. So I'm going to rename this. It's just sliding setup. There we go. I think we should be able to try this. I do want to set up the animation real quick before we continue any further with this. So when we press the button here, I want to activate the animation. And again, at the end here, I just want to deactivate the animation. So let's go and set up the animation for the character inside of the animator. So I'm going to go to the model. I'm just going to open up the animator here. Oh, there we go. Looks like we set up the sliding. So if we're just a refresher, I created a sliding variable here. I'm just going to copy that name. So if I assume I said if sliding is true, I turned off has exit time, and then over here, if sliding is false. So when we're in sliding, we are going to always be playing the sliding animation, and when we exit, we're going to go back to the standard animation. Okay, so looks like we did the animator as well, so I'm just going to go down here. Where am I? Activate sliding. So at the end over here, I'm just going to go to my object, grab my animator reference here, which is here. I'm going to type in animator.setBool. Remember, it's a boolean. I'm going to paste the name of that bool that I had, and I'm going to set that to be true. Because remember, we are sliding at this point. And I'm just going to copy those, and we'll paste them and change the outcome of that down here when we reset the sliding. Set that to false, drag that in here, and that should be the sum total of what we need for the sliding. It's just going to be, now it's a matter of tweaking. So the way you control a system like this for a dodge, roll, or slide is between tweaking the amount of time that we slide for and the sliding speed. So the more speed, the more multiplied. So if I make this value 300 up to 600, then I'm going to have to tweak the sliding value to be smaller. Or you're going to be sliding for half a second at a lot more. So you're going to cover quite a distance when you're in the level. So let's see if this works and how it works. So I'm going to kind of go to the side view here so you can see it. We're going to attempt to slide through here underneath and out the other side. So let's see if that works. If you're wondering, I'm now on the latest, it's 2020 version, 2020.2.4 F1. Okay, so let's see. There we go. Okay, so the slide wasn't long enough, and if you notice, I got stuck inside of the object. So we're just going to add a little more force. So I'm going to open up my variables here, go down to the bottom where my sliding force is. I think I'm going to make it about 350. Let's see if that's better. And then we'll be able, and then I also want to kind of see how the animation plays out. So I'm going to, I should have repositioned the camera first. Let me do that. Before we play, I'm just going to quickly reposition my camera so I can see if the animation plays. There we go. So we're going to slide. That looks actually quite nice. The animation. Okay, it's so close. So close. We are so close. So again, this is a matter of tweaking to get to your level design. And you'll notice in a lot of games, depending on what you're doing, maybe you want to constantly slide if you hold down the button instead of having a timer. You can tweak that just on input instead of anything else. But I'm going to give myself, screw it, I'm going 450. Let's do it. Let's go big or go home. Okay, let's try this one more time. But just to kind of show you why we adjust the collider is if I go to the wall here and I try to run through it, I can't because the collider won't allow me. But if I go and slide underneath it, because the collider changes height, but if I try to slide into this wall here, notice how because it's a collider, I can't slide through the wall because we're using physics-based. There we go. So there we go, that's working. So now we're sliding. We have a system that allows us to slide only forward. So you can tweak this as you wish. Maybe you could have different sliding animations, I guess, if you were running forward, backwards, left and right, you could set that up. But for mine, it's just, I just want to be able to slide in the direction that I'm going. There we go. So hopefully this has helped. I just want to do something really quickly, kind of give you an idea. I normally create some sort of checkered map texture in my levels to kind of see how much movement my character does when running through the world. But when I do a standard material where I add a checker, you can see that the different resolutions. So I would like to have the same resolution along everything. So let's just do that as a finale to this video. And in the next video, we will be covering the wall running, and in the video after that, we will be covering the grappling. So let me just make sure to apply this. Okay, so we're going to go into our materials folder here. I'm going to right click and create a new, and because we're using, what are we using actually? Oh no, okay, we'll do that in the next video. I'm going to switch over to Universal Render Pipeline or HD Render Pipeline, depending on which one I would like to use. I think I'm going to stick with URP just to kind of show you guys now that you have ambient occlusion in there, so which is really cool. They finally have screen spaced ambient occlusion, so I can show you guys how to set that up. Okay, so that's it. So up to this point, our character can run around, the character can jump onto objects, and the character can slide under objects. So the next step is to do wall running, and then to do grappling, and then finally to do some sort of bow ammo kind of thing. That would be cool. So as we go, I'll just kind of see what I need to add onto that. So thank you so much. Sorry for the wait. Hopefully this helps. I'm going to be releasing the next video quite soon. Now that my PC is up and running, I feel like I've gotten a little bit behind. But thank you so much for your support, guys. Until I speak to you again, be safe. Cheers, everyone.